Welcome, folks, to our weekly YFTT Yugabyte Friday Tech Talks. This is a talk, by engineers for engineers, so it's going to be pretty technical. And you guys, please feel free to ask any questions you have just by typing it on the LinkedIn comment box. You can also talk to us by joining our community Slack, so yugabyte.com/Slack, and go to the YFTT channel, and we'll answer questions there for you as well. Again, this is meant to be an interactive session, so please do ask questions if you have any. All right, so I have with me Bala. I think, why don't you quickly introduce yourself, Bala, and then we can get this going.
Yeah, thank you, Karthik. Thanks for hosting me here. And yeah, my name is Bala, working as a field engineer in Yugabyte, Bangalore. Yeah.
Awesome, thank you. And Bala is very modest, but he helps a lot of users figure out everything, right? Like right from their data models to performance to all of the end-to-end solution. How do you get something up and running? So yeah, I think it's been phenomenal working with Bala. All right. So yeah. So tell us, Bala, what is this about? CDC from YugabyteDB to Elasticsearch. So talk about what are some use cases. Look, what do you have for us?
Definitely. Yeah, this is an interesting connector or a
you
sync.
want to maybe slide share?
Yeah.
Yeah. So,
Sure.
Yeah. Okay. Perfect. Yeah.
Yeah. Thank you. So yeah, YugabyteDB to Elasticsearch sync is one of an important connector where nowadays many of the cloud native applications are looking for search based apps, which the search based services which they need to do it. So this particular connector is really helping us to how we can offload some of the transactional data to Elasticsearch, where it will help them and enable the full text search and all those things. So that's something we are going to talk about it, and a lot of different use cases like how retail, how internet of vehicles, and all those things are going to really use that. And this is very easy to implement. So this doesn't require any additional infra. So like how we will just show the demo. Yeah, to start off, as you said, this is an important for modern cloud native applications nowadays, where people are really looking a large volume of data to build a search on top of that. That's not an easy thing from a traditional database or even any unstructured database. So that's where YugabyteDB offers such sort of data types where we store today the JSON-based fields or even any text-based data. We can easily offload such a large volume to enable them the classical full text search, where they can send a lot of queries, which is not a native SQL kind of a queries, right? So that's the power of Elasticsearch, which will help us to quickly give the results back. And it is also keeping the data in historical form to where we will enable to build a lot of analytics in future. It will even supply the data back to data warehouses. And it is also helping us to even asynchronously communicating to different remote system like data warehouse can offload this data. Even Elasticsearch can supply this data back to any different systems through REST APIs, because Elasticsearch is just giving all the data through the REST API call, so people don't need to really build any REST layer on top of it. So it's very user friendly from that perspective. So this marriage of YugabyteDB to Elasticsearch is very important in many use cases, but we thought of take one of the interesting use cases like how e-commerce search applications in the retail industries are using. As we know, like YugabyteDB is really helping today to store a lot of retail transactions, where for many of their customers who come for product catalog or even looking for the pricing list, even it tracks care of order management. Where they really need is more of unstructured data, like textual data, where they want to really see how the product reviews are, what is the sentiment of the product, or can I build some sort of a Q&A, or I can even enable a chatbot. So they need to look for a different solution. So this can be taken off easily by having a connector of Yugabyte CDC connected with Elasticsearch. So we can just run both on the same plane, where people can just uh, divert the microservices to one layer to Yugabyte, another side to Elasticsearch, where they can combine the results of the same data which is flowing from YugabyteDB to Elasticsearch, and that way they will be getting a search as a service, which is really helping through this integration of CDC, what is coming from Yugabyte to Elasticsearch. So whenever I modify a catalog, or whenever I add a new product, or whenever I change my pricing list, I don't need to worry how quick it is getting back to Elasticsearch, because this connector will immediately ingest the data through the Logstash engine, and then it will be storing there. So that's how where it is more powerful for search-based apps in the modern era. Like many of the cloud native applications are really looking such sort of unification between these two, Karthik.
Got it. Got it. Makes sense. So, like, for example, if I go to Amazon.com or something, and then I search for a product, and then I click on the product, and then I order the product, right? It's
Right.
actually the search is hitting the Elastic side, the click is hitting the YugabyteDB or whatever. I mean, in their case,
Absolutely.
whatever, yeah, the database side, and it goes back and forth. Similarly, when I place an order, it goes to this side, and when I search my orders, it goes to the other, right? And this is you're trying to say is a seamless integration. Okay. So,
Absolutely.
all right. Interesting. So let's see how is this done. So let's keep going.
Yeah, definitely.
More
Another
examples. Yeah,
interest.
more examples. Okay, go for it. Yeah.
Yeah, yeah. I will take one more example. So here, this is where Internet of Vehicles is now getting where more of familiar from an autonomous vehicles, or where it carries a lot of sensors nowadays. So it's difficult to learn the data in a large database and then you apply the model or learn the model on the fly. So that's where edge analytics is an important use case for Internet of Vehicles, where today YugabyteDB is able to store such sort of IoT data coming from different sensors. So where we can store with the actuators or the IoT gateway data or even the direct devices data, we will leverage these Elasticsearch with where a lot of ML models are being plugged in with the standard machine learning models, or we can even custom models can be plugged inside. This way, these models will continuously getting the stream of data from Yugabyte itself, where YugabyteDB is helping them to supply these data seamlessly, where they can historically collect, learn, and even they will just train it well and make sure these edge analytics will work and back to the vehicle what it is looking. So this is how the vehicle can predict, okay, what is the speed that I need to drive on this lane, or what is exactly going to happen on my vehicle. So all those things need spot decisions than a traditional data analytics where it takes some time and then give a some sort of latency perspective, right? So this way, this is more powerful for Internet of Vehicles or any IoT data which needs an edge analytics. Elasticsearch can complement along with YugabyteDB and solve those sort of use cases seamlessly.
Yeah, makes sense. Makes total sense.
Yeah, another interesting use case is where data scientists don't know like how to query our YugabyteDB today, like which table to go for it and what table I have to query it. Can I use this column to get those values? They don't need to worry all those things. As soon as you enable the Elasticsearch sync with YugabyteDB seamlessly gives those data back to your Elasticsearch. And that's how where they can build the dashboards with all exploratory requirement, like how this data is coming and what sort of histograms I can build it, whether the data is correlating each other or not. Then this will help them to choose the right model, maybe a correlation model or a regression model or a time series model based on like what sort of data will help me from YugabyteDB when it is available in the Elasticsearch. This way, they can save a lot of time, like looking at the data. Apart from YugabyteDB, they can even have another look of Elasticsearch, which is going to have a lot of history. This will even help them to choose the right model and go for it with the data warehouse where they can build it. This will be acting as like an entry layer or a staging layer to go for any sort of algorithms or model that they can take it from there.
Yeah, makes total sense because on one side you can do ad hoc, on the other side it's more very fast access patterns, right?
Absolutely, yeah. Yeah, so how it works, so this is how like so where it is not a complex architecture where the change data capture in our previous sessions where we already explained, this already comes along with our DBCM connector and Kafka engine, where we can stream those selected tables or whatever the tables that we can bring it to Kafka. So that will all being as a taken as a topic that will continuously stream from our logs, where we can just consume based on the connector that we are going to use it. In this case, we are going to talk about Elasticsearch. Like our Elasticsearch is even following the similar architecture, and how this is just taking the data from the same stream and how exactly it is going to use it. So as you can see the left side, so this is our database layer. So where we are continuously streaming the data through our DBCM connector with the YugabyteDB, and then it is where the Kafka part which is coming. And Logstash is basically taking and ingesting those Kafka topics, parses it, and then transform it like whatever messages you want it. That will be indexed and kept it into Elasticsearch DB. From there, Kibana can help us to visualize, build the models, even build any sort of dashboards seamlessly through the data, where it will be continuously refreshing from Elasticsearch.
Got
So
it.
the
So
flow is,
just to understand this, this is going to transform whatever transactional data, the Debezium connector will transform it into a format that, Kafka can ship to Logstash, and
yeah.
who converts it? So somebody else on the other side converts it from the Kafka whatever format to a Logstash format, or does Debezium convert it directly to a Logstash format?
Yeah, the beauty of the thing is we don't need any transformation. So we can directly take the as is message coming from our Debezium JSON message directly
You
to
just send it
Elasticsearch.
out to, okay.
Absolutely, absolutely. Yeah, that's exactly what I'm explaining in this diagram. So we'll be just taking the same topic. Here we are just taking the same JSON message. We are not filtering anything. We are just filtering only those messages which are applicable to us. And then we are just dumping to the sink of Elasticsearch with that index name.
Yeah,
So no additional transformations required, Karthik, in the middle actually.
makes
So that's,
complete.
yeah, exactly. That way we don't need any additional development effort to really transform these are doing it actually.
Got it. And one question that Kurt has is if you have any examples comparing how certain queries are expressed in Elasticsearch versus Postgres. Do you have examples, or maybe you can just talk about it?
Yeah, definitely. I can talk about it. I don't have that live example. Yeah, a simple example maybe something like I have a JSON field of let's say some 15 different 15 different columns inside the JSON field, right? So it's like a nested complex JSON, where if I need to query it in Postgres, where I need to really look for like how I have to take this array value properly. Even if I did a simple mistake, my JSON will not give the result. So this sort of challenges I don't have if I offload this JSON data to Elasticsearch. That's how where I can just give those entire string or a simple string. The job of Elasticsearch is it is already indexed and it will go and find it where exactly these values are there and what are the corresponding rows which is having that value. So that way my query is even more simpler than a complex query, what I'm going to write it on the database side.
Makes sense. Yeah, makes sense. And Rajagopalan has a question. In case of downtime, data ingestion between YugabyteDB and Elasticsearch might not occur. And in that case, our search results will be impacted. Is that true? Or is there any offline ingestion? So I think the answer probably is if there is downtime
Yeah,
and it comes up, it will send the remaining portion, right?
absolutely. And it is also adding to another solution or another answer to that question is like how we are building our HA architecture also seamlessly. If we have a good HA architecture in built, we don't need to worry about our downtime in terms of keeping our resiliency and everything in place. So this will also, the same CDC will flow, even one or two nodes in our side is down actually.
Yeah, makes sense. So yeah, so two answers to that, right? Like downtime you can avoid by putting HA architecture. So you can
Yes,
always keep pushing. And even if there is downtime and it comes up, there's checkpointing. So you can start from the last known offset, right? And go from there.
absolutely.
All right. Awesome. Awesome. Okay, let's keep going. Yeah.
Thank you. So in terms of enabling this Elasticsearch sync, what are the things required at your end? So you need to plug in. Why? Because YugabyteDB is using the Kafka integration. So through the Debezium connector, so where you need the input as Kafka, what we explained here. So the output is where you need the Elasticsearch to store the data through the index, like what you are going to bring it. So this is exactly what you just need to install those plugin, like I just given the command here for the input as well as the output. Once it is done, that's all. So the next thing is like you just need to run this configuration by adding your topics or list of tables, what do you want to stream back to Elasticsearch from YugabyteDB. So that will start flowing seamlessly to there. So the middle layer where it is important, like you can take a call. For example, you don't want to dump all the JSON. In case you feel out of my table, 100 fields are there where my text fields are only important, like 5 or 10, then you can give a JSON with that field. The alone can go to your Elasticsearch. This way, your index size is going to be smaller, and it is even more faster when you are going to retrieve for your search applications. That way, you can control the transformations also at this layer.
Makes sense.
Yeah, so let me run through the demo. So I'm thought of quickly run through these three scenarios today, like how this is going to work for a web application, which is a cloud native pet clinic application. And another some sort of queries like how Geoparty data that we loaded in YugabyteDB, how we can even enable that, and what are all the different dashboards that we can build with the dev tools and other things. Let me just go to the demo straight away.
Yeah, let's do it. Demo always fun.
Thanks. Yeah, so this is my the pet clinic application. So first of all,
could you
what
make
is
the font size a little bigger, Bala? Like maybe Apple
yeah,
Plus
sure.
or something. Yeah, just so. Yeah.
Yeah, is it better?
Yeah, maybe one more. Just so. Yeah.
Yeah.
Yeah. Perfect. Yeah.
Yeah, so this is a pet clinic application. So when I look at the pet clinic applications, as you can see here, so this is the you can see already Yugabyte sample application. One of them is like we use the Spring data, like how Spring data can be complemented along with YugabyteDB to uh, uh, build the
And for
applications.
context, this is the standard sample application for Spring, right?
Absolutely.
Well, this
Correct.
is the application, the Hello World equivalent for Spring, or not a Hello World, slightly more than that, but yeah.
Yeah, yeah, it is much more than that from the Spring data perspective. Yeah. So yeah, as you can see, this application is self-explanatory, where it just have those pets and those owners and the veterinarians, like just to do a simple CRUD application. So here, what I'm just going to do is like I'm just trying with a simple thing like um, how I'm entering the data, maybe just simple application, right? So this is just going to help us like how this data is going to now coming to YugabyteDB and immediately available to Elasticsearch. So now I entered this data. As soon as you add the data, so I'm just going to see like, okay, whether my streams are coming here. So you can see already the data, whatever I added. So this is all being passed. So now let me um, just run the Kafka logs and see whether this has come up. You can see here the pet clinic is already started streaming it. So let me just put.
Yeah, maybe make the size also a little bigger, Bala, here also. Yeah. Just Apple
Yeah,
Plus.
sure. Yeah, yeah. Is it
Yeah, it's good.
better?
Yeah.
Okay. I'm just started the CDC process. So in my machine, I already have the Dockers are running. So if I just to show what are all the things I'm currently running for the CDC. So this is the Yugabyte Debusium connector and supported by the Kafka and Zookeeper. So these are all the three Dockers which is currently helping me to stream the data from YugabyteDB to Elasticsearch. So no additional components I
Zookeeper is
installed.
for Kafka, correct?
Yes, that's right.
Yeah,
Zookeeper is
makes
for
sense.
Kafka.
Yeah.
In this machine, I already have my ELK up and running. So I don't have any additional Dockers. That's why you can see only 3 Dockers here.
Yeah.
So now, as soon as if I just uh, put any data to my database, so I can go and just see like how my Logstash configuration is there. So here I created a configuration. This is my Logstash folder. So as you can see, this is the pet clinic stream. So let me just put. Hope it's visible.
Yes, this is fantastic. Yeah, yeah.
Yeah. So this is a my local Kafka, which is taking my topic. Like I've taken the pet clinic owner and the pet details, which whatever I kept it. And then I'm just bringing those messages, the JSON, whatever the standard message coming, and I'm dumping into my Elasticsearch, which is running in 9200. So that's a pet clinic index. So as soon as you just see that, so there is already an index which is being available here. So you can see the pet clinic index.
So one question, Bala, what does source message mean? Is that the name of the field?
Yeah, the source is a message, or it can be a stream, like the different tags of what is supported by Kafka, basically.
Right. Okay.
This
And
is
the
related.
target is of the format JSON. Got it. Okay.
Absolutely. Yeah. Yeah. As you can see, this is my Elasticsearch. So I already have my index being created. So just to show like what are all the tables I loaded for pet clinic. As you can see, this is my pet clinic schema, which is the standard schema, what is comes along with our sample application. So I have just used only this owner and pet, as you can see here. So as soon as I entered the data, now the data has to go to my pet clinic Elasticsearch. So this is the pet clinic Elasticsearch index. What I did, this is the Kibana dashboard. So what I did is here, I just taken my index name pet clinic, which is star. So I have taken that, and I can see all my JSON fields, whatever Yugabyte is already having it in the schema. So example, as you can see here, like what is the name of the pet, what is the last name of the owner. So because I'm bringing both together, it is not a, though it is a separate table in YugabyteDB, but it is combined as one single message here when I'm streaming the data to Elasticsearch. So it will be just indexed on the same index where I can supply all the fields. So I'm having both the owner data and the pet data. I can query either one of them here. So for example, now I just refresh the data. As soon as you can see here, like, so there are 55 rows are there. I can go and find it out, like whatever I entered, like what is there. So you can see here, like, so what I entered. So it is appearing here. So this way, at least I feel that, okay, I don't need to query anything. I can directly query the value, so that I don't need to supply like what is my field name or what is the equivalent JSON field name I have to worry. So that's not the case of the Postgres example. Like, we need to really know the schema well. Here you don't need to know the schema. I can just know the index. I can query the rest. So that's the advantage here. The another interesting application I just thought of take is the next one, which is the Jeopardy gaming. As many of the gaming applications are getting built in YugabyteDB, as we know, and we are already supporting a lot of our customers on the gaming development, like how they can seamlessly build. So this is a classic example. I just thought of show like how this Jeopardy data is there. As you can see here. Um, so this is my this is my Jeopardy schema. So I
Yeah.
just created the Q&A table. So as you can see here, my Jeopardy is having just very limited columns specific to the game, like
Yeah.
what is the show ID, what is the show number. This is standard data I just downloaded from the previous gaming data. So how this is important, because this is where the textual data I was explaining, right? Like we have huge text from a question or answer. So this is where people need like a classical full text search where they can offload these sort of data directly to Elasticsearch, where they can build even a good a dashboard or even sort of a searching applications where they can find it out rather than querying heavily here. And they also felt that, okay, my index may not sufficient or I need to add more index. This is how where we can do that. Now I'm just going to run some uh, quick insert and see like how this is going to stream it to Elasticsearch. I just created 4 more records just
Yep.
to sample magic show. Now I'm just going to see the messages are coming as soon as you can see. These are anyway running and you can see the data is coming there.
Yeah.
Um, Now let's go and see the Jeopardy data, which is already been created here. So this is how like where I can just go and refresh it. So as soon as I refresh, I will take today's data only. So whatever I just entered magic, as you can see, now you can see that all my 4 records of Q1, Q2, Q3, Q4, A1, A2, A3, all are appearing here. Whatever I entered here, you can see that. So
Fantastic.
this,
Yeah.
yeah,
Yeah.
this is where the live streaming is really enabled, right? So that's how where we can see immediately. You really see there is not much latency. Of course, there is few milliseconds latency or a seconds latency, but still your Elasticsearch apps can be quickly built. So this is how where you can take out the advantage of the CDC connector of YugabyteDB, how you can quickly build your search app through Elasticsearch as well.
Fantastic. Fantastic. Awesome. These are great demos. And I think fully functional dashboards, everything. And this is amazing to see.
Yeah, thank you. Yeah, another interesting thing of Elasticsearch is like people may think of, okay, if I need to load the data into YugabyteDB, because this is a typical OLAP, sorry, not a OLAP database. It's a pure OLTP or a transactional database. How I do my data analysis? Because I need a data analysis worth of 1 year data or 2 year data. Where do I dump it before I will take it to my OLAP database? So this is where they can at least think of this machine learning and anomaly features are there. So when we look into the machine learning feature of Elasticsearch, as soon as you stream the data to Elasticsearch, you don't need to do anything. You can just leverage the standard feature of anomaly detection. As long as your data is having those time series based data, you can quickly build those model and you can vet it. Okay, whether my sanity of those transactional data is good from a data quality perspective or a data sanity perspective, whether the future I can build with the right data set, I'm going to build the model. Either it can be a predictive model or a prescriptive model or any time series model. This tool can really take a quick and dirty check where we can think of what model can be built or not, right? Or whether any anomalies are there. Or then I can even think of, okay, a lot of duplicates are there. Then I need to apply some controls on my applications to even more validations at the front end to make sure my data is even more quality and it is having right data to the right audience. So these are all the quick checks we can do with the sort of machine learning models. And this also has an histogram kind of a future where I don't need to really build my histogram future. So for example, even you can take off the geoparty data. So where I already loaded like 145K worth of data. So I can see here like what are these top categories are there
Yep.
out of this. Yeah, so I can quickly go and build it. I don't need to really worry like what is there. Yet this doesn't require any sort of queries where I need to really worry it about. Okay, these are my top values. Okay, whether this categorical model I can build with this, whether this is trustable, then I can associate and go back to that histogram and check that. So this way, at least we have a lot of features. Once we integrate our CDC connector of YugabyteDB, we can build a lot of things on top of it, Karthik.
Makes complete sense. Yeah. Thank you. Thank you. That was awesome, Bala. Fantastic demo. Okay, so Mohan has a question, which is, do you have a perf comparison metrics for text index in Postgres versus Elastic index?
Honestly speaking, I don't have anything right now, but I
Yeah.
will come back to you. Yeah.
Yeah, I think also Mohan, it's important to figure out like exactly what kind of index and how you do it. So if you there is some overlap between OLTP and search, right? Like in the sense OLTP is really good at, if you know your access patterns, you can index them and make it very quick. Whereas Elastic will do a scatter gather, like which is like all the data is indexed in memory, all nodes will work and pour through data and get it back. So whereas a OLTP engine will go look for the precise piece of data and return it to you. I think something like a text index, it really depends on how you do the text indexing, right? If you have a large blob of text and you're starting to do, regular expression matches, all of that stuff, then an OLTP engine can zero down to that area and then go do some stuff. An Elastic like engine will, perform better if, like, for example, as Bala said, any of my document, do they have the word John, right? It's very good for something like Elastic because it indexes all data in memory. But if you say for a particular field is the value John, then an OLTP index, because you're going to ask that question often, is going to be quite good. So it really depends on the use case. But yeah, I don't know if, probably don't have metrics here, right? As Bala said. Awesome, fantastic. Other things, any other comments, thoughts, Bala, closing comments, thoughts? Because one observation I had was that, all these three things that you used, effectively, it's Yugabyte, it's Kafka, and it's Elastic, right? They're all cloud native technologies. They're all
Right.
scalable, resilient, fault tolerant, all of that stuff. So the question that Rajagopalan asked before, which is what happens in the case of downtime, is actually quite interesting in this architecture, where you should be able to prevent downtime across the board, right? Like, so because that is the purpose of cloud native. So it's just an interesting observation.
Absolutely. Another interesting thing is like it's again the tale of two distributed system, because Elasticsearch is also an equally a distributed architecture.
Correct.
Where we are definitely complementing those to them directly. So that way the massive scalability or even fault tolerance or the HA perspective, even Elastic can handle very well with this. Yeah.
Yeah. And last observation is, I think in the fully managed cloud, right? Like we actually simplify this a little more. Is that right?
Yeah.
Like, where we can do the push directly, right? Like we don't even need if the volume isn't too big, we don't even need a Kafka in the middle.
Absolutely. Yeah, definitely we can even push that, because the Logstash has the beauty of even it will take from our direct JDBC connectors as well, because it supports JDBC or even we can dump some of through flat files if we have our batch jobs, where we can even supply that. So if we feel the Kafka is going to be a overkill for us, we can even do that way, like it can at least takes the storage from how our CDC can stream the data to the middle layer. From there, it can even take it up, not even directly from Kafka as well. Yeah.
Awesome. Fantastic. Awesome. Thanks. Thank you for the presentation, Bala. And Kurt and Todd both say it's a great presentation. Thank you. And thank you guys, Kurt,
Thank you,
Todd,
Karthik.
all of the others for joining. Once again, join us next week, same place, same time for another YFTT episode. And, in the meanwhile, you can just join our community Slack, yugabyte.com/Slack to ask us questions. Just go to the YFTT channel. Yeah, thanks everybody. And thank you, Bala, once again for staying up and doing this. This was a fantastic demo.
Thank you so much, Karthik. Thanks again. Thanks, everyone.